Okay, so in this video, we're going to learn how to graph exponential functions. Okay, we're going to look at how to graph them. Now, the best way that I can give you for graphing an exponential function is basically to plug in numbers and see what you get for those numbers. Okay, and I'm also going to show you how you could graph these using Desmos as well. Okay, so if I wanted to graph f of x equals 3 times 2 to the x power, okay, so it says sketch the graph of each function and state its domain and range. Okay, so first I'm going to graph it. So the first thing I'm going to do is plug in a 0 for x. Okay, if I plug in a 0 for x, hopefully you remember that anything raised to the 0 power is equal to 1. Okay, if you don't, write that over here to the side. 2 to the 0 equals 1. Anything raised to the 0 power equals 1. So if I do that, this would be 1 times 3 would be 3. So I would have the point 0, 1, 2, 3. And if you'll remember, we said earlier when we talked about the properties of exponential functions that 0a would always be a point. And so my a is 3 here. So, of course, 0, 3 is a point on this graph. All right, what if I put in 1? Okay, if I put in 1, 2 to the first power is 2, and then 2 times 3 is 6. So if I put in 1, I'm going to get 6. 4, 5, 6. Okay. What if I put in negative 1? Now you're going to have to remember your properties of exponents here. 2 to the negative 1 power. Okay. I'm going to write that over here. 2 to the negative 1 is the same thing as 1 over 2 to the first, which is 1/2. So basically what you're doing is taking half of 3. So half of 3 would be 1.5. So if I go to negative 1, I'm going to get 1.5, which is here. Okay, so hopefully you'll be able to see that this graph is going to come down like this, and it will continuously approach this x-axis. Remember, the x-axis is the asymptote, okay, that these approach. So this is going to continuously approach the x-axis, which is the asymptote, but it's never going to touch it. So I'm going to mark your asymptote down here for you. This would be the asymptote. It would continuously approach that line, but it's never going to touch it. Now, the domain of all exponential functions is negative infinity to positive infinity. It's always that, okay? Your range, and I gave this to you in the previous video, but I'm going to refer back to it. Your range is the set of all positive numbers if a is greater than 0. So my a is greater than 0 here, it's 3. And you can tell your range are your y values. So they're going to be everything from 0 up to infinity. So my range is 0 to infinity. Okay, let's look at one more. 2 times 1/4 to the x. Okay, again, if I were to just take some points and plot them, hopefully you will remember that 0, negative 2 is a point because 0a, our a here is negative 2. So that means 0, negative 2 is a point on this graph. Okay, looks like that. What if I put in 1? Okay, if I put in 1 here, 1/4 to the first power, that's 1/4. And then 1/4 of negative 2 is negative 0.5. That's negative 1/2. So if I go to 1, I'm going to get negative 1/2, which is this point. Okay, what if I put in negative 1? Okay, if I put in negative 1, now remember, we know that this line is coming up because it's approaching this asymptote of our x-axis here. Remember, this is our asymptote. Let me mark that for us. It's our asymptote. So we're approaching it. So if I put in negative 1, 1/4 to the negative 1 power, and you can do that. I'm just going to do it right here for you. If you've got a calculator, you can do that on your calculator. 1/4 raised to the negative 1 power. That gives you 4, okay? Basically what you do is flip that, okay? So 4 times negative 2 would be a negative 8. So negative 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. That's all the way down here. So we can tell that this graph is going to come up and do something like this, and it's going to continuously approach this asymptote, the x-axis, but it's never going to touch it. So it's coming up and it's doing this. It's continuously approaching it. Now for our domain is always negative infinity to positive infinity. And our range this time it's all the values down this way. So this time they go from negative infinity up to 0. Okay, pause the video at this point and you try to do this one and then come back and I will have worked it. Okay, hopefully you worked this you try problem here. So we're going to look here, x and y. All right, we've got 0, 2 we know is a point on the graph. So I'm going to go ahead and put that 0, 2 because 0a is always a point. And then if I put in 1, okay, 1/2 raised to the first power is 1/2, and half of 2 is 1. So I'm going to have the point 1, 1. Now we know, hopefully you mark this, we know that this is our asymptote down here, the x-axis, okay? What if I put in 2? 1/2 squared would be 1/4, and 1/4 of 2 is a half, 0.5. So at 2, I'm going to get 0.5. So you can see how that's coming down. So let's do a number, let's do -1 and see what I get. 1/2 to the -1 power will give me 2, and then 2 times 2 is 4. So at -1, I'm going to get 4. 1, 2, 3, 4. Let's do one more, -2. 1/2 to the -2 power would give me 4, and then 4 times 2 would be 8. So at -2, I'm going to get 8. 4, 5, 6, 7, 8. That's this point here. So you can see we have a graph that does something like this, and it's going to continuously get closer and closer to that x-axis, but it's never going to touch it. Okay, your domain, the domain of all of these is negative infinity to positive infinity. And the range is everything positive. So this is going to be 0 up to infinity. All right, guys, as always, if you have questions, let me know.